Okay, now we're going to look at the last set of special angle pairs when I just have two lines intersecting, and they're called vertical angles. One cool thing about them, and you'll notice it on my word wall, is vertical angles, they kind of make a V. So you have this upside, the V up on top and the V on bottom that's turned upside down. That's a vertical angle pair. Now also you have a wide V over here and a V over here. That's another vertical angle pair. So, what are vertical angles? Well, when any two lines intersect, they form linear pairs and vertical angles. The vertical angles, as I mentioned earlier, are opposite each other. It's like they're pointing at each other. Now I'm going to set up this situation where I'm just trying to deal with how do vertical angles behave for any measure. So I'm not telling you how big angle CBD is. I'm just saying it's 8 degrees. And let's see if we can figure something out about the relationships. Well, I know that this angle right here plus this 8 degrees has to be 180 because you can see right here there's a straight line. All right, so that must add up to 180. Then I subtract a from both sides, kind of like I'm finding the expression for an angle, and I get 180 minus a. So I'll go ahead and fill that in. Now I'm going to try the same thing with this angle ABE here. So, measure of angle ABE plus this angle has to be 180. I'll subtract 180 from both sides, and then I get measure of angle ABE minus A is 0. Add A to both sides, and I get the measure of angle ABE is A. So that's also 8 degrees. Now I could continue this on for DBE, but hopefully you'll figure out that this angle is going to be the same as angle ABC. So what does this all mean? What can we conclude? Well, you can see this angle pair here is congruent. And this angle pair, ABC and DBE, are also congruent. So this shows that vertical angles are always congruent. And when you're going to solve for something in them, when you set up an equation, you just set each of the vertical angles equal to each other. You're not adding them. You're putting one on one side and one on the other and put an equal sign. So here's our example. I want to find angle ABE and angle DBE, the measures. One thing I notice is that I have a pair of vertical angles. So I'm actually not going to do ABE first because I don't have enough information to find it. But I do have enough information for DBE. I have an expression for the vertical angle. So I set the two angles equal. 3x equals 5x minus 36. Subtract 5x from both sides, and I get negative 2x is negative 36. Go ahead and divide both sides by negative 2, so x is 18. Now I'm going to go ahead and find angle DBE. It would be actually easier to find ABC and then say, oh, it's the same, but I'm going to go ahead and do DBE. So DBE, the picture says, is 5x minus 36. That's a given. Substitute in the 18, and I get 5 times 18 minus 36, or 90 minus 36, which is 54. So I can say the measure of angle DBE is 54 degrees. Now I can go ahead, if I'm trying to find ABE, I know that this angle here plus the 54 has to add up to 180. So the measure of angle ABE plus 54 is 180. Subtract 54 from both sides, and the measure of angle ABE is 126. So I put the 126 in there. Now I also know CBD because it's a vertical angle to ABE. They have to be congruent. And I also know ABC because it's opposite DBE. They're vertical angles, and those two are congruent. So further reflection. Why are vertical angles always congruent? How do you set up an equation for vertical angles? And can two vertical angles be supplementary? Why or why not?